Welcome to today's webinar on Failure Mode Effect and Analysis, FMEA. Presenter for this session is Mr. Aravinth. All attendees are put in the mute mode and if you have any questions, then feel free to post it in the chat window. So the Aravinth will address the same at the end of the presentation. This webinar is being recorded and available offline on our YouTube channel. So now Aravinth, it's over to you. You can start the presentation.
Okay, very good afternoon. This is Aravinth. Today we are going to see the module FMEA, Failure Mode Effect and Analysis. This is the one of the reliability tasks, and this is in RAC, Reliability Analysis Center. They have made this as a very important task. 70% of the people in the survey, they have voted for this one. And that is the very important task in the reliability analysis, because in reliability there are a lot of other activities also is there. Today we are going to see only the failure mode effect and analysis. So failure mode effect and analysis is, it's a systematic engineering process. It's a systematic approach to identify to focus majorly on what are the potential failure modes and what will be the effects, and in order to how to improve the product or any process. Like for example, if you are saying any product means it may be the electronic product, it may be any mechanical or automotive product, any of these products. So how to prevent the problems when designing the systems or any product we can say. So like what are the methods is there to do this? Method is majorly failure mode effect and analysis, FRACAS, and one more analysis, that is failure reporting and corrective action system. So here we are going to see only failure mode effect and analysis. If you are considering the criticality of the system means, then we call it as a FMECA. This is a failure mode effect and criticality analysis. So to reduce the risk and increase the safety of the system, in order to improve that one, we are trying to use this FMEA approach. Basically, we call this approach is the bottom-up approach. From the component level, how it is affecting my system functionality or any process. So how to reduce this one? Using this FMEA analysis, we can do that one. So first of all, we want to see the history. What is the history for this FMEA analysis? Means in mid-60s, in aerospace industry, like whichever the Boeing company, or aerospace companies, satellite companies, they are started using this FMEA analysis. Majorly because there and all safety and risk is involved, there they will use this FMEA analysis. Majorly in India or all over the world, defense companies and the aerospace companies, they are using this analysis. So next industry is the chemical industry, because there also safety is required, risk also involved. The safe chemical companies means there are a lot of processes there. The chemical or any material, it have to undergo several processes. So how to improve how to minimize the effects or failures, how to do this one, we can do it through this methodology. Afterwards, if you see the automotive industry, they adapted this FMEA techniques. For majorly for them, lot of improvements it is able to do, because if you are doing any automobile company or any electronics company, first they will invent one system. For example, if I take one missile means, what they will do first, they will do one missile for it will go and hit the target for 10 kilometers. So the next system maybe it will go for more than 25 kilometers or something. Because next generation or newer version, whenever they are doing, they want to what are the drawbacks they have faced in the previous system, that they have to overcome in the new system to avoid those failures, to improve their system quality and the system. This method is very useful to do. So there are some simple terminologies are there by this approach. What is failure, what is the failure mode, and what is the cause, and what is the effect. So these kind of terminologies are important. So for example, I am saying the inability of the system is the failure. So system means we can call it some PC, personal computer also we can call it as a system. Whichever the designers trying to make one system means that is the system. So for example, if one system means there are so many other subsystems also will be there, like subsystem 1, For example, if I am taking one computer as a system, means inside that system so many subsystems. For example, if you say motherboard, hard disk, then RAM, so different types of subsystems are there. If anything is not working, means that we call it as a failure. So failure mode we should know. What is the failure mode? Failure mode means a physical description of manner in which a failure occurs. For example, if you say, if you take an electronic components, most of the people who are attending are basically electronics. So if I am saying in electronics, means if it is a resistor, means there are two types of failures are there for a resistor. One is open circuit, that is one type of failure, and short circuit, that is one more type of failure. So this is failure mode. Failure, short circuit or open circuit, anything is a failure. In which mode it is there? Open circuit failure mode or it is a short circuit failure mode. So different types of failure modes are there. So that is one more terminology. So what is the cause of failure? So we should know which one is the cause of failure. So some particular failure, what is the root cause? What is the origin of that particular failure? We should know the failure mechanism. If this resistor is got failed, because of this resistor, power supply is stopped going to the system and the whole system is not performing. So this is root cause. We should know how the failure happens. So that particular item is not working. What is the reason for that particular failure? We should know. That is the root cause of the failure. Then effect. Some failure is happened. Then what will be the next effect? So if power supply is got failed, means my whole system is not working. That is the effect. So my system is not working, or particular motor, stepper motor, this is not working. Any this kind of effects we call it as effect of failure. So what is the causes? Potential causes failure means here some more examples I have shown. Some poor solder, some particular solder if you are not doing properly or in a particular heat means, so that is one kind of failure. Cause of failure. Or if you are stressing more, if it is an electronic component, if you are giving over stressing the components, then we used to call it as that is one cause of failure. So there are so many different causes are there for any failures. So what so many effects? Here some more examples for the effects. Here if you see loss of power or any noise if it is coming or any loss of particular functionality. So there are so many different types of potential effects of failures are there. So this is here I am given as examples. So apart from that, so many other failures also is there in the any systems. So there are levels are there. Item means any component. For example, if you say if it is a resistor or if it is an integrated circuit like IC or any processor, means one item having different modes of failure. So short circuit, open circuit, if you say incorrect timing, there are different modes of failures also is there. So for one mode of particular failure, so many different causes also is there. So one item having different types of modes and one mode having different types of causes, and for each cause there will be some effect will be there. So this is the level. So item, under the item different modes, and different modes under that one mode different causes, and each and every cause having different effects. So here we are, if you are doing any FMEA, you have to follow some standard, because already some path is there, already some road is there. So we have to follow that particular path. If it is a aerospace or a defense project, means you should use the MIL standard 1629 standard. So if it is an automotive industry, means AIAG method is there. So if you are doing any non-automobile application, means SAE method is there. So different types of standards are there because their products are different, the end products are different. So different products having different standards. So first we will see the MIL standard. MIL standard 1629. This standard is given by Department of Defense US. They have made this standard. So already some pre-made standard is there, means better can follow that standard. And so many softwares also they are incorporated this standard into their software. So the methodology and approach will be much more easier to do this analysis. So MIL standard 1629. In that there are different types of tasks are there. So task 101 is the failure mode FMEA task. 102 is the criticality analysis. Then 103 is there. For FMEA maintainability information, 104 is damage mode and effect analysis. Because each system have to undergo some certain analysis. So for example, task 101 and 102 are the majorly following tasks in this FMEA analysis. And different types of FMEAs also is there, because there are three types of FMEAs are there. One is process FMEA, functional FMEA, component level FMEA. So process FMEA means if you are doing any electronic system means inside that system there are a lot of different components are there, PCBs are there. In that PCB, varieties of processors like processing unit, A to D converter, so many components are there. Because each and every component we should handle in a different manner. For example, if you are making a PCB assembly, in that assembly, if you are a processor, if you are touching in your bare hand means then there is a failure or some effects will be there in the particular component. So how to handle those particular components? Processors means how to handle those components. So like electronic, electrostatic protection, anything you have to use. So these kind of guidelines you have to give it to the assembly people. Assembly in the sense like who are doing the PCB assembly, you have to give some guidelines. If they are not properly handle those particular components, what will happen? It will affect the performance of the particular component, then it will affect the PCB level, then the whole system level it will affect. So these kind of processing details, you have to give the guidelines to the whoever handling those components. You should give some guidelines to the process FMEA. So that is process FMEA. If you, for example, if I am saying functional FMEA means, so what are the functional level failures? One system is there. For example, if laptop is there means what type of functional failures it will come. So for example, if mouse is not working, that is one type of functional problem. If for example, your motherboard is not working or your processor is not working, some particular functionality level if I am speaking means that is functional FMEA. Functionality level means my display is not working. So my keyboard is not operating or my particular action is not taking place. My LED is not glowing, power LED is not glowing. This is different types of functional FMEA. The same point of view, if I say in a component level FMEA. Component level FMEA is single point failure. My processor is not failing. My processor is not working. My LED is not glowing. Or this is very single point failure. So if that particular component is not working, my whole system may not work or my partial system may not work. These kind of problems will come. That is component level FMEA. So we should know where we should use component level FMEA, where you should do functional FMEA. For example, my system is very small or my system may be very huge. So small level system, we should go component level FMEA we should do. If my system is very huge, more than 500 PCBs or 550 PCBs I am using in one particular system, then it means that there are lakhs of components are there. I can't speak the component level, so I can speak in the functional level only, how my top level system is getting affected based on the particular components or particular functional activity. If I am speaking in that fashion means that is functional FMEA. In each and every component or particular critical components, or if the particular component is failed, my whole system will fail, or the major functionality of my system will get failed means that we call it as a component level FMEA. So when if it is a very huge system, we should go with the functional level FMEA. If it is a small system like component level, we can define my system means then we can use the component level FMEA. So here you can see the severity and occurrence, because any particular failure mode is there. For example, here you can see the CPU failure mode. Here I have mentioned. Under that, how severe it is. I should know which is the severity level. If it is a catastrophic means this whole system failure, or my system is getting crashed or damaged, or if any human failures, if anything is happening, that is the catastrophic. More severity. The critical level is there, marginal level failure is there, then minor failure is there. So minor failure means we are doing some maintenance activity without any, it is not in the regular list. We are doing unconditional maintenance. We are doing, but it is not a planned maintenance. We are doing means that is minor level. Marginal level, some particular functionality only it is not working. Critical level means some particular subsystem or some part of the system is not functioning, means that is critical level. So we should know, the designer should know which level my severity is, this particular failure. So occurrence, what type of occurrence it is happening. So for example, it is happening very frequently, or it is a reasonable failure, or it is occasionally anything it is happening, or any remote level failure, or extremely unlikely. We will never expect that this kind of particular failures, it's never won't come. So those kind of failures, this is the occurrence list. So based upon the severity and the occurrence, we will decide the risk level. So whether my system is in a high level risk or a low level risk, or it is in a medium level risk. So what type of my system risk is involved, my system is. So from that, we will do the criticality matrix. Based on the severity and occurrence, my system, it is in a low level problem or a high level problem. Through the criticality matrix, we can define. So because here for each one, we are having different types of values are there. Some values we have mentioned. According to this value, multiplication of these two, we can define the risk level. My system is in which risk level. So that we can define through this criticality matrix. This is the FMEA MEL standard. Based on the MEL standard 1629 we are doing. And here one more important thing is there. What it means, FMD is there. FMD 97 means failure mode mechanism distribution. FMD, which means that for each and every component they are having different types of failure. Because capacitor means it will having some typical types of failures only will be there. Or any microprocessor means apart from that some 5 to 6 failure modes, there won't be any other failure modes. So this kind of failure modes for each and every component, diode, transistor, processor, what type of component, electronic components for each, not only electronics, but mechanical components also. For each and every component, there are different types of failure modes also it's available ready. Directly for this failure mode, what is the chance of this system failure, that we can define. So qualitative analysis, this is the qualitative analysis. Then the next method is automotive industry, whoever they are following this method is RTN method. RTN method is risk priority number. Based on the what will be the local effect, what is the next effect, what will be the end effect, and how severity occurrence. Based on that, we will define the RTN number. So that we will see. This method is AAG method. AAG, potential failure mode and effective analysis. Based on this is for the automotive industry, and we can use it for electronics also. We can use it, but whenever we are using any FMEA analysis, they will mention like customer or the supplier, whoever who want this FMEA, they will mention according to this standard you should do the FMEA analysis. So severity means there are different types of severities. For that, each one different types of ranking is there. So severity is 10 means dangerous is high. If it will injure your customer or it will injure the company employee, or system failure. So there are different types of severity level here they have mentioned. So for example, if you see extremely high, very high, moderate, low, very low, minor, very minor. So from this ranking level, the designer easily he can define what type of this failure will cause the system level, this particular component or particular failure, how it is affecting the system. So he can define easily based on this severity rankings. So the same way occurrence also is there. So what a very probability of failure means, it's very high means failure is almost inevitable. You can't do any very high. You can't identify the what type of failure it is. So that is we are giving most rank. So like this high, moderate, low, very low is there. And possible failure rates. We should know what is failure rate. Failure rate means basically the frequency of failure. So simple example, if I say means, if you are buying any TV, like any LED TV or LCD TV, anything, if you are buying, we will ask the warranty period, how long my system will work. Like they will give some 1 year warranty or 2 year warranty. Your system may work more than 1 year or 2 year, but minimum that system never fail within this particular period of time. So based on this failure rate only, they will define this warranty period. So failure rate means basically for a million hour my system, how long my system will work, how many hours my system will work. So the lifetime of my system failure we can define. That is the failure rate. Basically frequency of the failures. How frequently my system is going to fail. Minimum it will work for this many years. After that only the system get degraded. Then it started giving some problem or some particular component failures will happen in your system or any product. So next one is the detection. What is mean by detection? Means detection is an assessment of the ability of the proposed control identifying the potential cause, any design weakness. So any design weakness before it is released to the production. Because in the designer level itself we should define this this one. We are detecting the design weakness. Because before reaching to the customer, what are the types of failures I should reduce when the product is reaching before the market. Anything in the designer stage itself, I should reduce the design weakness. So what are the failures? I should reduce that one. For detection also some ranking is there. Almost impossible. You couldn't able to detect this kind of particular problem. I don't know how the system is getting failed and what type of failure mechanism this happened and how to identify. I don't know this type of failure. For that kind of failure, we used to call this detection ranking is 10. Almost impossible to define that particular failure. How to detect that one? Are very low, are low, moderatively high, are very high. So couldn't able to find. For that also detection method is there. And one more thing here, if you, for example, if you take one simple system keyboard means some method is there. If caps lock is on or off, some method is there to detect. So how the LED is glowing means then caps lock LED is glowing means it is on. So this kind of clock signal for my system, clock signal if it is coming or my power is switched on, my power is capable or my power is the exact power what for my system it is coming. So these kind of details, some identification method is there, some detection method is there. So for example, caps lock means if it is on means that LED will glow. So this kind of very huge system means I should not probe and test my whether this processor is working or my clock signal is coming or my signal system is synchronous or not. These kind of details, a detection method how to be there. If this LED is glowing means that then I should know my system is synchronized and my system is started working. So if this LED is glowing means my clock signal is working fine. So this kind of detection method you should follow because every time you can't probe and test my system whether my system this is working, functioning is correct or not. So some detection method you should incorporate in your system. Whenever some particular failure is happened, seeing that LED or seeing that display itself, I should know this kind of failure is happened. So this will make you to system availability. You can improve it easily. So some particular clock signal is not coming means it's just some simple reset button. If you press, then automatically system will start running. So these kind of detection methods also you should follow. So what is the risk priority number? It is the product of severity, occurrence, and the detection. So because each and value, the highest value is 10 and the lowest value is 1. You should not give 0. Whichever the higher priority you should take care of is, if you multiply these 3 values, whichever is giving the highest value, you should do the FMEA analysis for that particular component. So after doing one more thing, which is the most severe one, you have to give more importance to that particular severity. Which is the severity ranking is more means we should give the more importance to that particular component. So multiplication of these 3, we will get our value which is giving the highest value. You should take action in the corrective action. So corrective action means you should know which is corrective action. So for example, if you are using any system, means in that battery is there, that battery is expired, like that battery is charge is down, or there is no, that battery is capacity, battery is weak. So what we should do, simply you are replacing with one more battery, which means that this is not the corrective action. Corrective action means you have to change the design, that is the circuit level design change, anything if you are doing, that is the corrective action. So corrective action, what corrective action you are giving, no, that is the recommended action. So that is the recommended action. So what we should do is, we should recommend some actions. So this is because in FMEA analysis, the customer and the customer complaints, what are the customer complaints, and the quality division person and the testing person, who is the designer. So everybody have to involve in this FMEA action. So because there will be a lot of suggestions will be there. From that you can find out what is the corrective action for this particular problem. So you should take some corrective action. After that corrective action, what are the things we can design changes, we can do it in your system, and you have to freeze the circuit. So the design, after that there should not be any change when the product is reaching to the customer. So these are the steps. Total these many steps are there to follow for the FMEA. Select the cross-functional team. So team means what I have told, no, like who is the testing person, who is the designer, quality division head, and the customer complaints, which are the previous system complaints, because that should not come in your next system. So whichever your previous system failure, that should not come in your next system. So what is the functional block diagram of the system? Functional block diagram means basically you should define your system. So we should know what are the components involved in this system, and how it is operating, and how the flow of the signal flow, and what will be the signal processing flow, that we should know. And what are the, you have to prioritize your activities. Which one is the first one, or which one is the second one, that you should prioritize. Then you should collect all the data, your system failures, previous system failures, all types of failures, you should take it. And afterwards, you should analysis, like this particular failure is happened, then what will be my effects. So how it is affecting my system. So results. So what will be the RPN information? Based on that only we should evaluate. So I am changing, I am confirming that one, and I am evaluated the system design, and afterwards I will measure. So what I should do means, whether my system is now working fine comparatively before, how it is working. So my particular failure is, I have taken any action, that action is helped or not. My situation is better than before. If that is the situation, means my system is working fine. If it is worse than the older this one, means then once again I have to evaluate the design action. Then once again I should undergo this situation. Then the same before, what my system, how it is failing, the same way now it is failing, means then I am not addressing the exact particular failure. So we should do it, keep on doing it over and again. Then your system failure will get improved, and any occurrences happen. Severity, any of severity will be there. For example, the system is there, any laptop, in that processor is the critical component only. So if the processor anyhow, if it is failed, my system will fail. So I should reduce the severity. So for example, if you see the laptop also, or if you see any personal computer PC, there will be a fan for the whole CPU. That CPU fan will be running, so it will reduce the heat of the processor. Still, the processor may fail. And what they will do, then they will fix one heat sink specifically for the particular processor. After fixing that heat sink also, my system is working better than before, but still my processor will fail because of overheating. So after fixing heat sink also, my system is failing, then they will attach the one smaller fan to the particular processor. So how they have done, they may not done in a single step these all the activities. They have done by one, they have done, then only they have finalized. Still, now my processor won't heat. So one specific fan for the CPU, then one heatsink for the processor. Still my system is getting failing. Then I will put small fan for that particular processor. So like this FMEA action, if you keep on doing it, then only you can reduce the system failure, and risk and safety will be more. This is the concept of FMEA. This we can do it in the reliability software, Relax. Now it is called as a Windchill quality solution product. So this is one of the module. So any questions, anything regarding this FMEA, you can ask me.
Thanks, Aravinth. Let's see if any question posted on the chat window. So far there is no question. Yes, and this webinar will live at our YouTube channel by Monday. So far there is no questions, so we can end our session now. So thank you, Aravinth. Thank you very much for your time, and thanks for this informative session. See you on the next session by 2:30. Thank you.
Thank you.